Hello everyone, and welcome to the Data Capstone Project Solutions lecture. In this lecture, we're going to go over the solutions for the 911 calls Data Capstone project. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the notebook. Let's go ahead and get started. First thing we want to do is import NumPy and pandas. I'm going to go ahead and say import NumPy as NP and import pandas as PD. And then the next cell asks you to import visualization libraries and set matplotlib inline. This was a little vague, kind of on purpose, but hopefully you realize it's just talking about matplotlib and seaborn. So I can say import matplotlib.pyplot as plt, import seaborn as SNS, and then I'm going to go ahead and say matplotlib inline. Next, we wanted to read in the CSV file as a data frame called df. So pd.readcsv, and we can actually just call 9 and then see 911.csv is the file we're concerned about. And then we wanted to check the info of the df, so df.info. So this tells us there's almost about 100,000 entries here, and there's 9 total columns. And then we actually have already the column descriptions up here in the notebook. Then we want to check the head of the df, and we can do that just by calling the method dfhead. And here we have the head of the df, so we can get a sense of what this actually looks like. Notice here the title has some sort of label, EMS, or fire, colon, and then the actual title event. Then we have a timestamp, TWP, which is a township, and if we scroll over to the right, we have an address and then that dummy column. Next, we want to answer some basic questions, such as, what are the top 5 zip codes for 911 calls? Well, we go ahead and grab the zip column, and then we can actually just specify value counts off of this. And that will return all the counts for all the zip codes, and we just want the top 5. So we just call head 5 off of that series, and here we have the top 5 zip codes. Next, we want to figure out what are the top 5 townships, TWP, for 911 calls. You're going to do a very similar thing. Specify TWP, call value counts, and then head 5, and this will get you these results. So Lower Marion, Abington, etc. Now we want to take a look at the title column and how many unique title codes are there. There's 2 ways of doing this. You can say df title, call unique on it, and this will return an array of all the unique titles, meaning you could just check the length of that array and get back the number. Or, to do this all in one step, you can just call nUnique. And that will also return 110. Okay, next up we want to create some new features. In the titles column, there are a reasons/departments code specified before the title code. And these are EMS, fire, and traffic. We want to use the .apply with a custom lambda expression to create a new column called reason that contains this string value. So for example, if the title column was EMS back pains/injury, the reason column for that value would be EMS. If we go ahead and take a look back at the head, like I mentioned before, there's some sort of reason here, colon, and then the full title. EMS, fire, and then later on there's traffic. Let's go ahead and create this reason column using .apply. First off, let's go ahead and break down the logic of what we want to do. I'm going to grab from title an example, ILOC, and this is kind of the way I like to do it, and then set this as X, and see what do I have to do to X to actually grab this title here. Well, since this is a string, I can say .split by colon, and then I notice that the title always comes first, so if I just grab the first element off of that list, now I have this reason here. Alright, this is the kind of thing we're going to do for our lambda expression. Let's go ahead and show that. I'm going to create the column reason, set it equal to the title column, .apply, and then say lambda of the title, then say title.split based off of the colon, and then I'm going to grab the very first item in that list. And let's go ahead and check out what reason looks like. And that's what it looks like. We have EMS, fire, traffic, perfect. All right. Hopefully that wasn't too hard. It can be a little tricky to express a lambda expression correctly with apply, a nice little hint for this is to just grab an example and then see what you have to do to that example, and then convert this into the lambda expression. Now we want to know what are the most common reason for a 911 call based off this new column. Well, that's actually quite easy. We can just call reason.valueCounts, and that returns that EMS is the most common reason. If you only wanted to return the most common reason, you could just say head1 and it would return EMS. But since there's only 3 values, we can just show all of them. Next up, we wanted to use Seaborn to create a count plot of 911 calls by reason. Okay, we're going to go ahead and say SNS count plot, and then we want to specify the x-axis to be reason here. So I'm going to say x is reason. Then for count plot, there is no y, since the y is automatically chosen to be just a count. So we're going to say data is df, and then run this. And here we have our count plot. Now, don't worry if you didn't get the exact coloring as shown in the solutions notebook. That's just a little extra call on the palette, so you could do something like palette equals, and the one I used for the solutions was just vary this. And that changes the color a bit. But don't worry of the color matching up or not. It's kind of an optional color mapping for you to choose. Hopefully you're able to figure out that count plot, x equals reason, and data equals df are the most important parts of creating that count plot. Now let's go ahead and focus on the time information. What is the data type of the objects in the timestamp column? Well, what you can do is just call df.info, and it will actually tell you, if you look at timestamp, that it's a object type. And this kind of gives you a hint that it's going to be not a number, and it's actually a string. And if we want to confirm that, we can just grab one of those objects. We can say timestamp.iloc0, just grab the first one, and note that we get back a string. If we want to further confirm that, we can say type, and here we have str for string. Something to note, if you just go all the way up to the top, this is confirmed right here with a string variable. Okay, let's go ahead and scroll back down. So we know we have times information, but it's actually a string. Now what we want to do is turn these timestamps into datetime objects. And we want to do that using pt2datetime. And if you go ahead and click this link, you'll notice here it's a link to the documentation on how to use to_datetime. You can go ahead and just check out the examples here. But it's actually quite a simple call, so hopefully you figured it out. But it's basically just saying pd2_datetime, pass in the column we want to convert. In this case, it's timestamp. And then I'm just going to reset that column to be equal to this. And now if I go ahead and take a look at this code right here, copy and paste it, now I have a timestamp object, which is exactly what we want. This is a datetime object now. Alright, now that it's a datetime object or a timestamp with pandas, we can actually grab specific attributes from the object by calling them. And there's a little piece of example code here. Let's go ahead and check that out. If I just copy and paste this example code, we can run this and show that we can actually grab information off of this. And then it says, use Jupyter's tab method to explore the various attributes you can call. And now that the timestamp column are actually datetime objects, use .apply to create 3 new columns called hour, month, and day of week. You will create these columns based off the timestamp column. And then you can reference the solutions if you get stuck on this step. Let me go ahead and break this down just a little further. If I go ahead and take a look at what time is that very first entry in this timestamp column. And note it says timestamp 2015 12:10 in the hour, minutes, seconds. If I do dot and call attributes off of this object, notice that I have a wide variety of attributes I can call. For instance, if I want to know the actual year this is in, I can just call year, and it will report back the year as 2015. If I want to know what hour of the day it was, it reports it back as 1700 hours, so in military or 24-hour format. If I want to know, for instance, the month it was in, I can call month, and I can even call things like day of week. So day of week is 3. And later on, there's actually a dictionary here for you to reference. All right, now what we want to do is have this ability of calling attributes off of this timestamp column to actually create an hour, month, and day of week column. Let me go ahead and show you how we're going to do that. We're going to say, for instance, df hour is equal to df of the timestamp column, and we're going to say dot apply, and we're going to say lambda, take the time, and then return the hour attribute. We go ahead and run that, and then if we check out the hour attribute, now we have all the hours where the actual call occurred off of the timestamp. And we're going to do the exact same thing for month and day of week. You can actually just copy and paste this line of code, and instead of hour for the first one, we'll go ahead and put in month and change this attribute to the month call. And for the second one, we're going to go ahead and call this day of week, and then change this to the day of week call. Now we go ahead and run this. Let's go ahead and check out the head of our data frame now, just to confirm that this all worked. And if we scroll all the way to the right, notice here we have 3 new columns. We have hour, month, and day of week, with some numbers to represent that. Okay. The next thing we wanted to notice was how the day of week is an integer from 0 to 6. Then it says use the .map method with this dictionary to map the actual string names to the day of the week. And what you have to do here, we can go ahead and copy this line of code. Now we have dmap, and then all you have to do is just map this. So you say df day of week equals df day of week, and then you can actually say .map, which is the method they're referring to here, and then pass in dmap. And now if we check out the head of our data frame, notice if we scroll all the way to the right again, day of week is now an actual string, Thursday, Friday, etc. So it's a little easier to read. Okay, now we want to use Seaborn to create a count plot of the day of week column with the hue based off of the reason column. Let's go ahead and recreate that. We can say sns.countPlot. X is going to be the day of week column. Data is going to be df. Remember, we don't need to pass in a y because we're just counting. And if we just do this, we get the total count per day of week. So we can see that there's a bit of a drop on Sunday. What we can add to this is the hue, specify that the hue is by reason, and we have a recreation of the plot shown in the solutions. Now something to note here is the color palette is a little different. If you want to use the same color palette I did, you can go ahead and say palette is equal to Viridis, and that reproduces the same color palette. And then the last thing to note is that the legend is actually out inside here. And in the solutions, we wanted to relocate the legend. You can actually just copy and paste the same code you did during the Seaborn lectures, where we actually show how to put the legend outside. If we go ahead and run that, now we have the legend outside of the plot itself. Alright, now the next task we had to perform was to do the same for the month column. And basically all you have to do is you can just copy and paste this code and change X to be month. And you'll have the exact same plot except it's for the month column. And then the next question was, did you notice something strange about this plot? And hopefully you were able to notice that you are actually missing some months. It goes 1 through 8, but then you don't have months 9, 10, and 11. It goes straight to 12. So now that we have noticed that missing information, what we may want to do is try plotting the information in another way, possibly through a simple line plot that fills in those missing months. And in order to do that, we'll need to do some additional work with pandas. We'll go ahead and stop part 1 of the solutions lecture here and carry on in part 2 by creating a group by object called by month in order to try to solve this issue. Okay, thanks everyone, and I'll see you at the next lecture for part 2 of the solutions.